Hi everyone, I will now be basically providing the solutions for the square root and the square root and the quadratic transformations exercise. All right, so I'm just going to read the question here. So for the first one, it says in each of the following sketch the original function, write down the domain and range, etc., etc. So I'm just going to basically use the screen, go back and forth to figure out what the original equation was, and then solve it. All right, so the first one was f of x is equal to the square root of x, and sketch the original function and write down the domain and range. So this is number one. So f of x is equal to, that's x, is equal to the square root of x. So sketch the function. So as we know, the function basically looks like this. The domain is x is element of reals, and x is greater or equal to 0. The range in this case is y is element of reals, and y is greater or equal to 0. Okay, now what was it? So write down the transform function g of x. So here it is, 2f x plus 1 minus 3. And basically do the same thing for that. So, so g of x is 2f of x plus 1 minus 3. I believe that's correct. Yeah, that's right. And so first let's write down what this function is. So keep in mind that x plus 1 is the argument, right? So all we're doing is we're taking this and we're plugging it right into x. So whatever x is being replaced by x plus 1. So in other words, if I had to write this, it would be 2 times the square root, and instead of x, I'm going to replace it with x plus 1. So I'm going to replace it with x plus 1. I'm just writing in red so it's clear what I have replaced. And then we go minus 3. So this is the equation that we want. And so we list the transformations. If you notice, like we can just look at right here, the transformations are, it's a vertical stretch by 2. It's to the left 1, and it's left because it's, over here it's inside the function, it's inside the input, and then it's down 3. So if we draw this, so the vertical stretch will basically stretch it up, like really high up. So it's moving left 1, so that's negative 1 here, and down 3, so that would be negative 3 here. So really, it doesn't really change the direction because there's no reflection, so it would go something like this. And since that's the direction, the domain is x is element of reals, x is greater than or equal to negative 1. The range is y is element of reals, and y is greater than or equal to negative 3. Okay, so that was number 1. Let's move on to number 2. So number 2, let me scroll down there. Oops. So negative 3f of x plus 4. Okay, so this is that, and g of x is negative 3f of x plus 4. So this one is just the same one as before. By the way, this is number 2. So it looks like that, and domain is always the same. Since it's just basic square root function, it's x is greater than or equal to 0. The range is y is element of reals, y is greater than or equal to 0. So basically, the argument basically stays the same. It's the same as x. So really, it's just negative 3 square root of x plus 4. What are the transformations? First, we see negative, so it's a reflection, and it's across the x-axis. It's x because it's outside the f and it's affecting the output. Then there's a vertical stretch by 3, and finally up 4. So what that means is, since it's reflecting across the x-axis, it'll go down this way. Vertical stretch by 3, so it means just it further stretches down this way, and then up 4. So basically, this is 4, because it moves up from 0 to 4, right? And so that's that. So the domain is x is element of reals, x is greater than or equal to 0, range is y is element of reals, y is less than 4, less than or equal to 4. So that's number 2. Let's do number 3. Let's look at that. Oops, it's right there. Number 3 is 2 f of negative x minus 1. 2 f of negative x minus 1. Now, as always, f of x is equal to square root of x. Let's do the domain and range. So d, x is element of reals, x is greater than or equal to 0. The range is y is element of reals, y is greater than or equal to 0. Okay, so if we look at this, now this is our f of x, so this is 2. The argument here is negative x, so we sub that in for the x. So in other words, it's the square root of negative x minus 1. And if we look over here, we see that there's a negative inside the square root function, so it's a reflection across the y-axis. Okay, it's a vertical stretch by 2, and then it's down 1. So what that means is if we follow, this is a vertical stretch across the y-axis. So this is the original function, so it would reflect that way. Vertical stretch by 2, which means it would just stretch in the y direction further and then down 1. So it's negative 1 here. So basically it's just going down this way, so, or in that direction. So the domain is x is element of reals, x is less than or equal to 0. 0 because it's just gone down, but like basically this point is still 0, so x is less than 0. The range is if you observe, it's greater than negative 1, so the range is y is greater than or equal to negative 1. Okay, let's move on to the next one. So number 4 is negative 3 f of negative x plus 2. So 4 negative 3 f of negative x plus 2. Let's see if that's correct. Yes, that's correct. Okay, so again, I kept this as is. There we go. That's the domain. That's the range. Right? It's pretty straightforward because we just drew the function. Now this one is just negative 3. Remember, this is the argument right here. It's substituting for x. So we get negative x plus 2. So if we look at, there are two reflections. This is across the x-axis. This is across the y. So it's a reflection across x and y axis. We see a vertical stretch by 3, because that's one there, and then it's up 2. So what that means as a graph is that this would it would basically normally go in this direction. Reflection across the s would mean it would go in this direction, and then another reflection across the y would mean it would go in this direction. And it's a vertical stretch by 3, so it just means that the y values would stretch further down by 3, and it's up 2. So it goes like that, and it goes in that direction. So the domain is x is element of reals. X is now less than 0. It's 0 because we're looking at the x's. It hasn't moved left or right, just moved up. So we're still at 0. So in other words, x is less than or equal to 0. The range is y is element of reals. Y is less than or equal to 2. And that's number 4. Let's go to number 5. 5 is 2 f of 3x plus 9 minus 1. Okay. So 2 f of 3x plus 9 minus 1. So let's do our f of x again, which, as usual, is the square root function right there. The domain is x is element of reals. X is greater than or equal to 0. The range is y is element of reals. Y is greater than or equal to 0. Okay, so if we observe over here, this is not factored. The argument is not factored. So it's imperative, very, very important, that we always factor our argument. So in other words, this is 2 f of 3 x plus 3 minus 1. And now that we have the factored form, we can just take this argument, this complete argument, and substitute it for x. So it's 2 square root of 3 x plus 3 minus 1. And so if we look over here, we don't see any reflections because there's no negative here or negative there. But we definitely see a vertical stretch by 2, and we see a horizontal stretch by 1/3. Don't forget the 1/3, because since it's inside the function, it's 1/3, and it's to the left by 3. So because there's a plus there, it's to the left 3, and it's down 1. So there we go. So if we have to draw this sketch, right? It's there's no reflection. So the vertical and horizontal stretch, they don't really change the direction. They just change the shape, but they don't change the direction. So this arrow would still be pointing. It would go vertical stretch by 2, so it would be there. Horizontal stretch by 1/3, so it'd still be pointing in this direction. Left 3, so this is -3, and then down 1, so this is -1. So that's the point, and we'd go like that. It's not my best arrow, but anyways, we basically get the idea of how this works. The domain in this case is, as always, so this is going to be x is greater than or equal to -3, and the range is going to be y is greater than or equal to -1. Let's go to number 6. So -2, 5 minus x plus 3. So g of x, -2, f of 5 minus x plus 3. Yes. So f of x, as usual as that, it goes like that. So here's the domain. X is element of reals, and x is greater than or equal to 0. Here's the range. Y is element of reals, and y is greater than or equal to 0. So if we look at this, again, we observe that this is not factored. So always factor that out. So we get -1, we factor out -1, and we get x minus 5. Right, so that's the factored version. Whenever we factor, you have to make sure whatever in the brackets starts with a single x, and so always factor out the number in front of the x, plus 3. So if we state the transformations, we look here, there's a reflection across the x and a reflection across the y. So reflection across x and y axis. There's a vertical stretch by 2. There's no horizontal stretch because it's 1, and then we can say it's right by 5 and up by 3. Right, because it's x minus 5 over there. So so in other words, there's a reflection across the x and y. So normally it would go like this, but a reflection across the x would make it look like this. Reflection across the y, like that. And the vertical stretch would just make it go further down because it's just stretching, but it doesn't change the direction. Right 5, so this is 5, and then up 3. So in other words, here would be our point, and it would just go in that direction. So remember, a rough sketch is only what's needed in order to just find the domain and range. So x is element of reals, and x is less than or equal to 5. The range is y is element of reals, and y is less than or equal to 3. Let's do number 7. Let's see number 7. Okay. So f of half x minus 3 plus 1. Okay. So here we go. So we see f of half x minus 3. Oh, sorry, did I have that right? Yes, plus 1. Plus 1. So I'll just do f first, as usual. So the domain is x is element of reals, x is greater than or equal to 0. The range is y is element of reals, y is greater than or equal to 0. Okay, so observe first that we always need to factor the argument. So it's half x minus 6, because half times -6 is -3 plus 1. And if you observe, there's no reflection, so no reflection, and there's a vertical stretch by half, and then there's a horizontal stretch by 2. Remember, we take the reciprocal when it's inside the function by 2. And it's to the right 6, and then up 1. So the stretch by half, so this is how it normally look like. There's no reflection, so we don't have to worry about the direction. Stretch by half would just basically make it stretch by half. It would still be in the same direction, and the horizontal stretch by 2 would still make it look further like this, but it would still be in the same direction. Right 6, so let's just say that's 6, up 1, so let's say that's 1. So in other words, it would go basically like this. So the domain would be x is greater than or equal to 6. The range would be y is greater than or equal to 1. All right, let's move on to the next one, number 8. Number 8. So negative f 6 minus 3x minus 1. So negative f 6 minus 3x minus 1. So if I factor, oh, actually, let me just do f of x, which is that. We know that's what it looks like. X is greater than or equal to 0. Here's the range. Y is greater than or equal to 0. So this is f. So if we factor this out, we get the negative 3. And we get x minus 2 minus 1. And it's minus 2 because negative 3 times negative 2 is positive 6. So, so let's look at the transformations. We see a reflection across the x-axis and the y-axis, across x and y-axis. There's a vertical stretch. Oh no, there's no vertical stretch, sorry. There's no vertical stretch, but there is a horizontal stretch. There's a horizontal stretch by 1/3. By 1/3, and then we can see it's right by 2, since it's negative in the inside the function. Right 2 and down 1, because it's negative 1. So, since there's a reflection across, so this is how it normally looks like. There's a reflection across the x, then the y, and it's moved to the right 2 and down 1. So, in other words, it goes like this. So, domain is x is element of reals. X is less than or equal to 2, because it's less than 2. The range is y is element of reals. Y is less than or equal to negative 1. Okay, so number 9. 4f of negative 3x plus 12 minus 2. 4f of negative 3x plus 12 minus 2. See if that's right. Okay. So it's 4f of negative 3x minus 4. Remember, we have to factor the argument minus 2. Oh, I forgot the original function f of x, which is that. So as always, that's the easy one. And it's the reason why I'm making you do this so many times is because I just want you to remember there should be like muscle memory, you know, whenever you see square root of x, you should automatically know what that looks like. So if we look at this, we see there's a reflection first of all. So it's a reflection across the y-axis. So it's a reflection across y. Okay, there's a vertical stretch by 4, a horizontal stretch by 1/3, right 4 because this is x minus, and then down 2. And let's see what this looks like. So reflection across the y-axis would normally look like this. So reflection across the y would look like that. Vertical stretch by 4 would just mean that's there by 1/3. So basically it would just still be in the same direction. Right 4, down 2. So this is where it is, and it would simply go in that direction. So here's the domain. x is element of reals, x is less than or equal to 4. The range is y is element of reals, y is greater than or equal to -2. All right, and number 10, the last one for this section at least, is -2 f of 2x plus 1 minus 1. So -2 f of 2x plus 1, what is it? 2x plus 1 minus 1, minus 1. So once again, we have f of x is equal to the square root of x. So our domain is x is element of reals, x is greater than or equal to 0. Our range is that. Okay, so remember we have to always factor this, so it's -2 f of 2x plus half minus 1. Okay, it's x plus half. So if we observe, what's the transformation? There's a reflection across the x-axis. Okay, there's a vertical stretch by 2, which is this one over here. But there's a horizontal stretch by half. Horizontal stretch by half. And then it's to the left too, because it's x plus half. So it's to the left by half, sorry. So it's left because there's a plus, so left half, and then there's down 1. Down 1. So let's see how that looks like. So reflection across the x-axis. So normally it would look like this, as we see over there, but since it's reflected across the x, it would go down like that. The vertical and horizontal stretch, I mean, they'll just change the shape of it, but they won't change the direction. And so it's left half, so this is negative half, and then down 1, so it's -1. So it's like that, and there we go. So the domain is x is element of reals, x is greater than or equal to -half, since it's going to the right, and the range is y is element of reals, and y is less than -1. Y is less than or equal to -1. All right, so that was section 1. Now let's move on to section 2. Okay, so in section 2, now we have the original function, we have some transformations, and we have to see how they'll change. All right, so let's go to number 11. All right, so here's our f of x as always. Okay, so here's the domain. X is greater than 0. Here's the range. Y is greater than 0. Okay, and let's look at the transformation. So reflection across y, vertical stretch by 2, and right 3. Okay, so reflection across y axis, so vertical stretch by 2, and then right 3, right? So in other words, g of x, right, it has to follow these transformations. So it's across y, so it's going to be, and there's a vertical stretch by 2, so it's going to be 2 f of -x. Because remember, they said reflection across y. So f negative x, oops, sorry, not correct there. So, and it says right by 3. So since it says right by 3, this is still within the bracket, so it's x minus 3, and this is our solution. Right, so in other words, what this is going to equal to is 2 square root of negative x minus 3. Vertical stretch by 2, right by 3, friction across y. So in other words, this will look like, so this is the original graph, reflection across y, and right by 3. So it's over here. And the stretch, remember, the stretch will just make it further, make the shape of the graph further up, but it won't change the direction. So it's going to go like that. So the domain is, as always, x is less than or equal to 3 because it's decreasing, and the range is going to be, since it's increasing up here, it's going to be y is greater than or equal to 0. Okay, so that's number 11. Let's go to 12. Reflection across x-axis, vs by 2, horizontal stretch by 1/3, and left 2, up 3. Okay, so a lot of info. So here's our f of x. Always draw the f of x just so you know what it looks like. Right, so x is greater than 0. Range is y is greater than or equal to 0. Okay. So let's look at the transformations again. Across x, vs2, hs 1/3, left 2, up 3. Okay, see if I can remember that. So reflection x-axis, right? So vs by 2, hs by 1/3, left 2, up 3. Is it up 3? Up 3, yeah, okay. Up 3. So let's see what g of x looks like. So there's a reflection across the x-axis, so we know there's a negative right away. Vertical stretch by 2, so that's great. So that's 2f of horizontal stretch by 1/3. So if it's 1/3, this means it's 3. And then it's going to be left 2, so it's going to be x plus 2. Okay? And then it's up 3. So that's what the function is going to look like. And then now we have to take this and substitute it for x, so it's negative 2, square root of 3 x plus 2 plus 3. Let's see what this looks like. So reflection across the x-axis, it means it's going to go down this way. Vertical stretch by 2. Remember, these don't really change the direction, they just change the shape. It's left 2, so it's negative 2, and it's up 3, so it's going to be there. So it's going to be there, and it's going to go like that. So the domain is x's element of reals. X is greater than or equal to negative 2, and the range is y is element of reals. Y is less than, because it's going downward, y is less than or equal to 3. Let's do number 13. Let's see 13. So reflection across x and y, horizontal stretch by half, right 2, down 4. Okay, so this is what number was that again? That's 13. Yeah. So 13. So here's my f of x as always. Sorry, my domain. X is element of reals. X is greater than or equal to 0. Range. Y is element of reals. Y is greater than or equal to 0. Okay, so so let's state the transformations again. It was reflection across x and y, horizontal stretch by half, right 2, down 4. Okay. Reflection x and y, horizontal stretch by half, right 2, down 4. Okay, so right 2, down 4. So g of x will look like, so there's the reflection across the x, so we know right away there's a negative. There's no vertical stretch, so we'll just assume that it's 1. So it's f, right? Now horizontal stretch by half, no, there's reflection across the y, so we know that there's a negative. Horizontal stretch by half, so which means it's 2. And it says to the right by 2, so in other words, it's x minus 2. Like, you have to be really careful inside the function, and then down 4, so it's negative 4. So, oh, right, and so what does this look like? So it'll be negative square root, because this goes into the argument there. So negative 2, x minus 2, minus 4. So what happens? So, all right, so this is the original function. It's reflected across the x and y, so we go here and then here. horizontal stretch by half. So that doesn't really change the direction. Right 2, so right 2, and then down 4, so -4. So in other words, it would just go like this. So the domain in this case is x is element of reals, and x is less than 2. X is less than or equal to 2. The range is y is element of reals, and we see y is less than or equal to -4. And that's our solution. Okay, so let's go to number 14. Let me scroll down a bit. 14. Vertical stretch by 3, horizontal stretch by 2, left 1, up 4. Okay. So here we go as usual. Nothing really fancy about this one. Let's do the transformation again. So here we go. Stretch by 3, horizontal by 2, left 1, up 4. Okay. So vertical stretch by 3, horizontal stretch by 2. I always forget this. Left 1, up 4. So left 1, up 4. So what g of x basically looks like is vertical stretch by 3. So it's 3 of f. There's no reflection, so we're fine. Now, since a horizontal stretch by 2, that just means it's a half. It says left 1, so it's x plus 1, okay, and up 4, so it's plus 4. So what that would look like is 3 square root of half x plus 1 plus 4. So we are going to the left one. So there's no stretching, so it would still go this way. Sorry, there's no reflection, so it would still go this way. Remember, the vertical and horizontal stretch, they'll change the shape, but they won't change the direction. It's left 1, so it's -1, up 4, so it's 4. So basically that's our coordinate, and go with that. So the domain is x is element of reals, x is greater than or equal to -1. The range is y is element of reals, and y is greater than or equal to 4. And that's the domain and range. Okay. Number 15. Let's go to number 15. Number 15 is, okay, so the square root of 3x is the original function. Vertical stretch by 2, left 2, up 3. Okay. So here we go. So f of x is something different this time. It's 3x. But if you graph this, remember, the only thing that we see is really just a horizontal stretch by 1/3. So that really won't change the direction. So it will still kind of look like this. It will still sort of look like this. And that point still 0, 0. It just means that everything is, all the inputs are compressed by 1/3. But the domain of this is x is greater than 0. The range of this is y is greater than 0. So no real change, except that you have to keep in mind that there's a horizontal stretch by 1/3. And let's look at the transformations again. A vertical stretch by 2, left 2, up 3. Okay. So vertical stretch by 2, left 3, was it? Left 2, up 3. Left 2, up 3. So g of x would look like 2 of f of x. There's no reflection, so no negatives. F of left 2, so it's going to be x plus 2, right? Up 3, so it's plus 3. So keep in mind that this is now the argument, and all this does is just goes right into x. There, it doesn't replace the 3x, it just replaces the x. The 3 still stays. So how will that look like? So what that would look like is 2, the square root of that 3 stays as is. And maybe I'll just write this in red. It'll be x plus 2. We're just replacing this x with the argument right here, which is x plus 2. And I'm going to write plus 3. So if we look right here, if I compare this to the original function, which is the square root of x, simply I see a vertical stretch of 2, a horizontal stretch of 1/3. I'm moving to the left 2 and up 3. So really no big difference. So this is my original function, square root of x, or I guess square root of 3x in this case. But if I just compare it to the square root of x, it would be this way. The vertical stretch is 2, so it wouldn't really change the direction, neither would the 1/3. That would be here, but it's to the left 2 and down. Oh, sorry, not down 3, but it's up 3. It's up 3 because of that, and it would still look like that. So the domain would be x is element of reals, and x is greater than or equal to -2. The range is y is element of reals, and y is greater than or equal to 3. So that's number 15. This one's an easy one because it sort of looks like our original square root function, but let's look at number 16 and 17 where they're a little bit more different and more interesting actually. Let's look at 16. So this is f of x is square root of 2x plus 4. So let's do this. Okay, so f of x is equal to the square root of 2x plus 4. So remember, even within the square root function, always factor. So it's x plus 2. So how would this look like? This basically, if we look at it, it's a horizontal stretch of a half, which really doesn't make a difference in the direction, but it's to the left 2, right? So this will go like that. So the domain of this is slightly different than any of the others we've done before because it's a slightly different function. This x is greater than or equal to -2, but the range is y is greater than or equal to 0. So that's our f of x. Let's see what the transformations are. Reflection across y, horizontal stretch by 2, and down 1. Okay, so of y-axis, hs of 2, down 1. Okay, so reflection across y-axis, horizontal stretch of 2, and it's down 1. Let me just make sure that's right. Yeah, great. So in other words, g of x is equal to, so reflection across y, which means, and there's no vertical stretch, so it's f of negative, and there's, so it's negative, since horizontal stretch of 2, that would just mean negative half x. And there's no left or right, so we can just close this one. And it's down 1, so it's negative 1. So remember, now what we're doing is we're taking this argument here, and we're plugging it right into just that x over there. Okay? So what that'll equal is the square root of 2 times negative, so maybe I'll write that in red. So negative half x, right? So that just replaces that x there. Plus 2, so this plus 2 is this one over here. And then don't forget the minus 1 to add that one at the end. So what we need to do here is we sort of need to expand this a little bit. So if we multiply this out, we'll basically get negative x, and then 2 times 2 is plus 4 minus 1. And if we factor this out, we'll get negative 1 x minus 4 minus 1. So this is what the equation looks like. And as we can see, there's a reflection across the y-axis, and it's 4 to the right and down 1. So look at this, reflection. So this is normally how it goes, the square root of x. Remember, now I'm comparing this function to just simply the square root x function. This makes my life easier than having to deal with this original function. So anyways, this is what square root of x looks like. Reflection across y would look like that. It's to the right 4, so those go. And then negative 1, so there we go. So basically it would look like that. So the domain is x's element of reals. X is less than or equal to 4. The range is y is element of reals, and y is greater than or equal to negative 1. Alright, so that is number 16. Let's try 17, which is, I think, one of the harder ones. Okay, so let's do this. 17, square root of x minus 2. We'll come back to square root of x minus 2. This just means it's translated to the left. Oh, sorry, translated to the right by 2. So, in other words, it just goes like this. This is 2. So, the domain is x is greater than or equal to 2. And the range is y is greater than or equal to 0. So we have that. Let's look at the transformations. So reflection across x, vertical stretch by 3, horizontal stretch by 2, and up 4. So x, 3, 2, 4. Okay. So reflection across the x-axis, vertical stretch by 3, horizontal stretch by 2. Let's double check that. And up 4. Up 4. Alright. So g of x basically is, since reflection across x, so it's negative. Vertical stretch by 3, so it's negative 3f. Horizontal stretch by 2, which means it's half of x. There's no left or right, so I can just close the bracket there. Up 4, so that's plus 4. And that's what it looks like. So remember, once again, I take this argument here, okay, and I plug it right into this x over here. I leave everything as is. So this is equal to negative 3 square root, let's put this in red, so it's half x, right, minus 2, and then don't forget that plus 4 at the end over there. So let's try to factor this. So this is half x minus 4 plus 4. Right, so I just basically factored what was inside. So what this tells me, in comparison to simply the square root function, is that there's a reflection across the x-axis, vertical stretch by 3, horizontal stretch by 2, right 4, and up 4. So in other words, remember, I'm not comparing it to this function here. It's a lot easier for me just to compare it to the square root function. So the square root function, in other words, reflection across the x, so normally it would be here, now it's here. Stretch by 3, so that's there. No other reflection, so that's still there. Right 4, and up 4. So basically, it would look like this. So the domain in this case is x's element of reals. X is greater than or equal to 4. The range is y's element of reals. Y is less than or equal to 4. Alright, so that's number 17. Let's look at 18. So 18 was section 3. Oops, here we go. 18 was section 3. In each of the following equations, sketch the original function, write down the domain and range, list the transformation maps from f to g, sketch g of x, and write down. Okay, so if you observe, what we're really doing is we're going from almost like a transform function to back to the parent or the original function, which is square root of x. So think of it backwards. If we had to go from g of x to f of x, we'd have to do a reflection across the x-axis, vertical stretch by 3, to the left 2, and then up 1. Okay, so instead of just following this, I'll just kind of write down how we do this. So basically, we're trying to go from f to g, right? That's our goal. But what I'm suggesting is let's figure out how to go from g of x to f. And then really what we'll see is we just have to work backwards. So f of x is, in this case, it's -3 square root of x plus 2 plus 1. Okay. So let me do it this way. So g of x is square root of x. F of x is -3 square root of x plus 2 plus 1. Plus 1. All right. So imagine if I'm going backwards. So this is what we're aiming for, but imagine I'm doing the reverse. I'm going from g to f. So what would I have to do? So the first, there'd be a reflection across the x-axis. Then there'd be a vertical stretch by 3. And then I'd go left 2 and then up 1, right? So really what I'm trying to say is that I'm just going to move something here. I'm just going to move this here. There you go. So really I'm just going from g of x to f of x. Now imagine what we're trying to aim for is we're trying to go from f to g. Okay? So imagine if you were to go from f all the way back to g. So if you wanted to go from f to g, so you would have to do the reverse process. So you basically moved up in order to get to f of x. So you'd have to go down 1. You move left 2. So if you're doing the reverse, you have to go right 2. Then vertical stretch by 1/3. So the reverse process would be vertical stretch by 1/3, not 3, but 1/3. So the reverse. And then the reflection is just a reflection. Now, it's not reflection across y, it's still the reflection across x. So it's reflection across the x-axis. The x-axis, and that would help you get back to g, right? Which is what we're trying to do. We're trying to go from this transform function to the original function over there. So we'd have to do this reverse process. So let me write this properly. So I'm trying to go from f of x, which is -3 square root of x plus 2. Was it plus 1 or minus 1? It was plus 1. Plus 1. And we're going from there to g of x, so which was the square root function. So we have to go backwards. So the steps are, so I'm just going to read that down. It's basically we go down 1, right 2, followed by vertical stretch of 1/3. You're just doing the reverse process, and then followed by a reflection across the x-axis. All right. I'm not going to draw this. I think you guys can figure out how to draw that. But really, just keep in mind that if you're going in the reverse process, you're just doing the opposite set of instructions. So, so that's number 18. I mean, I'm pretty sure you guys can write the domain and range and all that kind of stuff. Let's do number 19. So let's move on to number 19. So for number 19, we're basically going from f of x, which is, what is it? 2 square root of 4x plus 2 minus 3. 2 square root of 4x plus 2 minus 3. Let me just make sure that's right. And then we're trying to go to g of x, which is the square root of x. So keep in mind that if you observe, if we were to go from here to here, it'd be pretty simple, it'd be straightforward. Vertical stretch of 2, you'd have to factor this and figure that out and all that good stuff. Actually, let me just factor that. So remember, always factor your argument. So plus half, because 4 times half is 2, minus 3. So if I had to go from g of x to f of x, it'd be a vertical stretch of 2, horizontal stretch of 1/4, to the left half, and down 3. So, but that's not what I'm doing. I'm going the other way around. I'm trying to go from here to here. So we have to do the reverse set of operations. So basically it'll be up 3, and then to the right half, followed by a vertical stretch. Since this is a vertical stretch of 2, this will be a vertical stretch of half. Since this is a vertical stretch of 1/4, it'll be a horizontal stretch of 4. It's the opposite sort of set of transformations. And then finally, well, there's no reflection, so it doesn't really matter. So we're done here. So these would have to be the list of transformations to go from F to G. I'm not going to draw this. Just remember to factor this. You can get the domain and range of this, and then this we already know the domain and range for, and that's basically the process. So do the reverse step. This was down 3. That's why we said up 3. This to go from G to X. This was left half. So if you're going the opposite way, it's right half. We stretch by 2 in vertical direction, so we have to do the opposite, which is half. We stretch by 1/4, so doing the opposite, which is we stretch by 4. And no reflection, so we don't have to worry about that. And finally, number 20. Let's look at the 20. F of x is -3, 2 minus 2x minus 3. So f of x is -3, 2 minus 2x minus 3. And g of x is the square root of x. So always factor this argument, so -3, so we get -2, x minus 1, because -2 times -1 is 2, minus 3, and we're going here. So remember, we're going in the opposite direction, because it's easy. If we had to go from g of x to f of x, this would be easy. This would be very straightforward. We do reflections, then vertical stretch by 3, horizontal stretch by half, and then to the right 1 and down 3. So we're going the opposite. But that's not the way we're going. We're trying to go from F to G. So if we're doing that, we just have to do the reverse set of operations. So in other words, since this is -3, this will be up 3. And since this is to the right 1, this would be left 1, followed by, since this was a vertical stretch of 3, if we were going from G to F, so this now the opposite of that is vertical stretch of 1/3. Since this is a horizontal stretch of half, and we're going from G to F, the opposite would be a horizontal stretch of 2. And since there were reflections in the x and y, we just go back to that. So it's a reflection across the x and y. We don't really change the x and y. If there was a reflection across the x before, we just do the same thing again. It'll just flip it back. So reflection across the x and y axis, because that's how it went. All right, so in the next section, we'll just do the quadratics. All right, let's move on to number 21, which is in section 4. So 21, and now what we'll be dealing with is the quadratics. So sketch the original function. So 2f(x plus 1 minus 3). Okay. So here's f of x, which is simply x squared, and this just looks like that. All right. So the domain is element of all reals, and the range is y is element of reals, and y is greater than or equal to 0, because it starts at 0 and simply goes up. Let's do g of x, which is 2f(x plus 1 minus 3). So 2f(x plus 1 minus 3). So remember, all we're doing is we're taking the argument here and we're plugging it in for x. So this becomes 2, and So that's squared, and what's inside is simply x plus 1 minus 3. So if we observe here, we see a vertical stretch by 2, left 1, and down 3. All right, so basically what that means, the vertical stretch is just going to stretch it even further like this. That's all it's going to do. But remember, oops, let me just change that a little bit. Wait 1 second. Yeah, so the vertical stretch is just going to stretch it vertically, so it's going to be a little bit thinner, but we're moving it left 1, down 3. So this is -1, and this is -3, so that's our point, and basically it just goes up like that. So the domain in this case is still the same. In fact, the domain will always be the same unless there's some restrictions in the domain, but the domain will always be the same, which is x's element of reals. It's really the range that keeps changing. So y is greater than or equal to -3. Okay, so there we go. Let's do number 22. 22, -3 f of x plus 4. Okay, so this is the same as before. So g of x is -3 f of x plus 4, -3 f of x plus 4. And since nothing really changes, it's just going to be -3x squared plus 4. So as you can see, there's a reflection across the x-axis. There's a vertical stretch by 3, and it's up 4. So what will it look like is it's going to go, now this is the original, it's going to go down now because of the reflection. It's going to be stretched further, so it's going to be a bit thinner, and then up 4. So here's 4, and there you go. Okay, so domain is x is element of reals, and range is y is element of reals, and y is less than or equal to 4. Okay, number 23. Let's see here. 2 f of -x minus 1. So 2 f of -x minus 1. And this stays the same. Right, so that's how it's going to go. Domain is element of reals. Range is y is greater than or equal to 0. So this is just going to be 2, and once again, -x is now our argument, and we're going to plug it into x. So it's going to be -x squared minus 1. But what we can do is we can just square this. So it'll be 2x squared, and when you square a negative, it just becomes a positive. So it's 2x squared minus 1. So originally it would have been a reflection across the y-axis, but if you square it, we can just see it that there's no real reflection. So all we can say is a vertical stretch by 2 and down 1. So basically it's going to go down 1, so -1. So it's like this, and it should look a little bit more stretched. Actually, let me just change that. So it should look a bit more stretched like that. So the domain is the reals, range is y is greater than or equal to -1. That's 23. Here's 24. What is 24? -3 f of -x plus 2. Okay. -3 f of -x. Is it plus 2? Plus 2. So f of x is equal to x squared. So the domain is x is element of reals. The range is y is element of reals. Y is greater than or equal to 0. So if we plug this in, it's -3. Remember, we're taking this and substituting for x. So we're taking the argument here and just putting into x. And what that will do is, let me just, here, so negative x squared plus 2. And the thing is, if you square this, this simply becomes x squared. So it's negative 3 times x squared plus 2. So all we notice is a reflection across the x-axis, and it's a vertical stretch by 3 and then up 2. So in other words, oops, it's not a very good line. So in other words, it's going to be reflected. So this is how it normally goes. So it's reflected, so it's going down there. Vertical stretch by 3, so it's stretching further, and then up 2. So the domain in this case is the same, and the range in this case is y is less than or equal to 2. Uh, 25. It's 2f of 3x plus 9 minus 1. Okay. 2f of 3x plus 9 minus 1. Oops, no, I meant f of x. So simply equal to x squared. Right. Where is it? Oh, right. So the domain is x is element of reals, and the range is y is element of reals. Y is greater than or equal to 0. So in this case, the first thing you should always do is factor the argument. So it's 2f of 3x plus 3 minus 1. And now we're going to take this argument. We're going to take this argument, right? And we're literally going to plug it in right there. So this becomes 2, 3x plus 3 squared minus 1. So what you can observe is that there's a vertical stretch by 2, a horizontal stretch by 1/3 because of that 3. And then we go left 3, down 1. And what that would look like is really the vertical and horizontal stretch that won't affect the direction, and there's no reflection, so we're fine. So it's negative 3 and negative 1. So really it'll just look like, it'll be a very thin graph right there. So the domain in this case is x element of reals, and the range in this case is y is element of reals, but y is greater than or equal to negative 1. Negative 1 because it's greater than or equal to negative 1 there. Let's go to 26, which is negative 2f 5 minus x plus 3. 26. So 26, which is negative 2f of 5 minus x plus 3. Is it plus 3? Yes, it's plus 3. Okay, so, let's do f of x first, which is simply x squared. This is our basic one. So it's going to go up like that. The domain is x is element of reals. The range is y is greater than or equal to 0. This one, we always factor the argument. So it's going to be negative 2 f of negative x minus 5 plus 3. So we're just going to literally keep in mind that all we're doing is taking the argument and plugging it right into there. So it's negative 2, and it's negative x minus 5 squared plus 3. Now if you remember, this whole thing is being squared. So the square of a negative will just basically be positive. So it's negative 2 x minus 5 squared plus 3. And also keep in mind that the reason why these two are the same is that if we think about it, a reflection across the y-axis, right? If I reflect this across the y-axis, it'll look exactly the same. So it really makes no difference. So anyways, so what this means is it's a reflection across the x-axis, vertical stretch by 2, right by 5 and up 3. So, so in other words, it'll face down, and it's to the right 5, up 3. So here we go. So it's going to go down like this. So the domain in this case is still x is element of reals, and the range is y is element of reals, and y is less than or equal to 3. 27. 27 is half x minus 3 plus 1. Okay. Half x minus 3 plus 1. Let's do our basic one, which is x squared. So it goes up like that. So the domain is x is element of reals, and the range is y is greater than or equal to 0. Remember that we have to factor the argument, so it's f of half x minus 6 plus 1. So when you half times negative 6 is negative 3. So now all we're doing is we're just taking this and we're plugging it in right there, right? And so if we do that, we get half x minus 6 squared, because remember we're just replacing the x with that, and then plus 1. And so what you observe here is a vertical stretch by half, a horizontal stretch by 2, right 6, and then it's up 1. So, so what that would look like is it's right 6, and it's up 1, okay, and it's facing, so basically it'll go something like this. Okay, so the domain is x is element of reals, and the range is y is element of reals, and y is greater than or equal to 1, because it starts at 1 and then goes up. It starts at 1 and then goes up. Let's do number 28. So negative f 6 minus 3x plus 1. Okay. It's negative f 6 minus 3x minus 1. And this is equal to x squared. Okay, so the domain is x is element of reals, and the range is y is element of reals, and y is greater than or equal to 0. So remember, we have to always factor the argument first when we're doing g of x. So we get negative f of negative 3 x minus 2. The reason why it's x minus 2, because negative 3 times negative 2 is positive 6 minus 1. So if we look at it, we see, let's plug it in. So remember, all we're doing is taking this and substituting the argument right there. So since we're doing that, it's negative 3 x minus 2 squared minus 1. So, and if I square this, remember the negative inside will just become positive. So negative, so it's just 3 x minus 2 squared minus 1. So we can see that it's a reflection across the x-axis. Okay, it's a horizontal stretch by 1/3, and it's to the right 2 and down 1. So basically, we know that it's facing downwards. It's to the right 2 and down 1. Okay. And so the domain is x is element of reals, and the range is y is element of reals, and y is less than or equal to negative 1. Okay, so that's that one. Let's move on to the next. 29, 4f of negative 3x plus 12 minus 2. Let's do that. So 29. G of x is 4f of negative 3x plus 12 minus 2. Negative 3x plus 12 minus 2. Remember, our f of x is x squared, so as always, it would look like this. So the domain is x is element of reals. The range is y is element of reals, and y is greater than or equal to 0. We can factor the argument, so it's 4f of, you take out the negative 3, always take out the coefficient in front of the x. So it's x minus 4. Oops, not plus 2. Oh, sorry. So it's x minus 4 minus 2. And it's 4. And so remember, what we're doing is we're taking this argument here, and we're plugging it right there into that x. So this will simply be negative 3 x minus 4 squared minus 2. And keep in mind that this is a reflection across the y-axis, and if you reflect this across the y-axis, it looks exactly the same, so it really won't make a difference. And also, you know that because if I square it, the square of a negative is positive. So basically, this is the same thing as 3x minus 4 squared minus 2. So this is a vertical stretch by 4, a horizontal stretch by 1/3. It's to the right 4 and down 2. So this is equal to 4 there, down negative 2. There's no reflection. I mean, there was a reflection, but it was reflection across the y, which looked exactly the same as the original function. So, so basically it's just going to go up. And so the domain in this case is x is element of reals, and the range in this case is y is element of reals, and y is greater than or equal to negative 2. And let's do the last one for this section, which is negative 2 f of 2x plus 1 minus 1. So it's negative 2 f of 2x plus 1 minus 1. And as always, f of x squared, we draw that. This should go right through 0, 0. And the domain is x is element of reals, and the range is y is element of reals, and y is greater than or equal to 0. Here, remember, always factor the argument first. So you get 2x plus half minus 1. And remember, all we're doing is we're taking this argument here and we're plugging into the x value of f of x over here. So it's negative 2, and it's 2x plus half squared minus 1. And we can see that there's a reflection across the x-axis. There's a vertical stretch by 2. There's a horizontal stretch by 1/2. It's half to the left, because it's plus half here, and then down 1. So since it's a reflection across the x-axis, so it's facing down, the stretches won't really change the direction, they'll only change the shape of it. So it's half to the left, so it's negative half here, and down 1, so it's negative 1 here. So here we go, and it's facing down. So x is element of reals, and the range is y is element of reals. Y is less than or equal to negative 1, because it's less than or equal to negative 1 there. Okay, so let's move on to the next section. I'm just saving that right now. So I'll move on to the next section, which is here. So now we have some instructions, and we are going to basically do the stretches and see how everything looks like. So let's see, yeah, let's start with 31. So 31. Where's 31? Okay, so we start that. So let's just do f of x as always. Always write f of x because you'll see later on that f of x changes. It's not your standard basic function. So anyways, let's just see this. We've done this like a million times already, but this is x is element of reals, and the range is y is element of reals, and y is greater than or equal to 0. Let's move on to, okay, so let's look at the transformations. The transformations are reflection across the y-axis, vertical stretch by factor of 2, and right 3 units. So, reflection across y, vertical stretch by 2, and right 3 units, and right 3. So, in other words, g of x, always write g of x in terms of f of x. So g of x is basically a reflection across y. So it's, and there's a vertical stretch by 2. So it's 2f of negative. Now it's to the right 3. So it's x minus 3. And keep everything in factored form. So that's basically our form. So this 2 comes from vertical stretch, the reflection across y, that's why it's inside right 3, that's why this is inside the brackets. So all we're doing now is we're taking this and substituting it right there. So it's 2 negative x minus 3 squared. And as we basically said, when you square, see these are already in brackets, and if you square that negative, it'll become positive. So it's 2 x minus 3 squared. Now it doesn't really matter. The reason why it doesn't matter is because when you reflect your basic function, your x squared, if I reflect it across the y, it looks exactly the same. So that's why these two will be the same. Later on, you'll see examples where if it's moved to the right, where if you have a negative, it won't exactly be the same. And I'll explain why when we get there. So basically, this looks like it's 3 to the right. It's 3 to the right, and it's stretched by 2. So, right, so the domain is still the same. X is element of reals, and the range is y is element of reals, and y is greater than or equal to 0. 32. Okay. Let's do 32. So reflection across the x-axis, vertical stretch by a factor of 2, horizontal stretch by a factor of 1/3. Okay, let's reflection across x-axis, vertical stretch by a factor of 2. So always draw your basic one. It's very important. So what is that? Yeah, sorry. The domain is x is element of reals, and the range is y is element of reals, but y is greater than or equal to 0. It's reflection across x axis, vertical stretch by 2. Vertical stretch by 2, horizontal stretch by 1/3, left 2, up 3. Okay, horizontal stretch by 1/3, left 2, up 3. So g of x, in terms of f of x, is there's a reflection across the x-axis and vertical stretch by 2, so it's -2. F of, there's no reflection across the y-axis, so there's no negative here, but horizontal stretch by 1/3, which means this is 3, and it's left 2, so it's x plus 2, right? And then I'm closing the bracket there, and it's plus 3 since it's going up. And so recall that all we're doing is taking this argument here and subbing it in right there. So it's simply going to be equal to -2, 3x plus 2 squared, because that's the original function x squared, plus 3. And if you look here, it's a reflection across the x-axis, so it's going to go down like this, the stretch and the vertical stretch and horizontal stretch, they'll make it skinnier, but they won't, well, they'll make it skinnier, but they won't change the direction. And it's to the left 2, so it's -2 here, and +3, so it's +3 there. So there we go. So they'll face down. And keep in mind, it just doesn't go down, it goes towards the right, and this goes towards infinity to the left. So the domain here is x is element of reals, and the range here is y is element of reals, and y is less than or equal to 3, because it starts at 3 and just goes downwards. Let's go to the next one, which is number 33. So f of x is x squared. So the domain is x is element of reals, the range is y is element of reals, but y is greater than or equal to 0. So we have that. Now let's recall. So reflection across x and y, horizontal stretch by half, right 2, down 4. Okay, so reflection across x and y axes, horizontal stretch by half. I think it was left 2, down 4. Oh no, sorry, right 2, down 4. Right 2, down 4. So right 2, down 4. So what that means is g of x is reflection across x and y. So there's definitely a negative there. There's no vertical stretch, so we can just go right into negative f of x. Now across the y, so there's a negative there. Horizontal stretch by halves, which means this is 2. Right 2, so this is x minus 2. Because remember, inside the function, it's sort of the counterintuitive. And then down 4, so it's -4. So remember, all we're doing right now is taking this argument and plugging into the x over there. And so it's -2, x minus 2 squared minus 4. And this is equal to negative. You can square the 2 if you want, but I'm just going to leave it inside. If we square a negative, that's where this negative goes away. This negative does not because it's outside, but this negative is inside, it's being squared, so that's why it goes away. So in other words, the reflection across the y does not matter in this case. The reflection on the x, however, does. So what would that look like? So we know it's reflection across the x, so it's going to go downwards. It's going to be stretched by half, so it's going to be a little bit thinner. It's to the right 2 and down 4. So there you go. So it's going down there. And the domain is x is element of reals, and the range is y is element of reals, and y is less than or equal to -4. So y is less than or equal to -4. Okay, let's move on to the next one. So we did 33, let's do 34. So vertical stretch by 2, horizontal stretch by, vertical stretch by 3, horizontal stretch by 2, left 1, up 4. 34, is that 34? Yes, that was 34. Oops. So f of x is still x squared. Okay, so the domain is x is element of reals, and the range is y is element of reals, y is greater than or equal to 0. So g of x, let's do that again. So vertical stretch by 3, horizontal stretch by 2, left 1, up 4. So 3, 2, 1, 4. Okay. So it's a vertical stretch by 3, horizontal stretch by 2, left 1, and then up 4. Was it down 4? It was up 4. Okay. So g of x, there's no reflection here, so we're fine. So we can do 3. That's the vertical. So f of horizontal stretch by 2, so that becomes half. Left 1, so it's x minus 1. Oh, sorry, x plus 1, because it's left, it's counterintuitive, so it's x plus 1. And then up 4. And remember, all we're doing is taking this x, or this argument, and plugging into that x over there. So what this would be is simply 3 half x plus 1 squared plus 4. So that's the quadratic form. And since there's no reflection, it'll always be facing up. So, and it's left 1 and then up 4. So it's there. Okay, so the domain is x is element of reals, and the range is y is element of reals, and y is greater than or equal to 4. All right, so that's 34. Now, 35 is the more interesting one, because now our function is no longer x squared, it's 3x squared. So vertical stretch by 2, left 2 units, up 3 units. Okay, so let's try that. So f of x is equal to 3x squared. So what this is, it still looks like your basic x squared function, but that 3 means there's a vertical stretch. So it's vertically stretched by 3. So it should look a little bit thinner. But the domain and range won't really change because we haven't translated it or reflected it or anything. We just stretched it. So x is still element of reals, and the range is y is element of reals, but y is now greater than or equal to 0. Now, let's look at the transformations here. Vertical stretch by 2, left 2, up 3. Okay, so vertical stretch by 2, left 3, left 2, up 3. Left 2, up 3. So g of x in this case would simply be 2f of, and since there's no reflection, there's no negative, left 2, so it's going to be x plus 2, and then it's up 3, so it's plus 3. And remember, all we're doing is now, is taking this argument right here and plugging into that x over there, okay? So let's do this. Now this one's a little bit tricky. So first, don't forget that 2. That 2 is over there, okay? So we're going to put the f in this bracket right here. So the f starts with the 3, okay? And instead of that x, we're going to substitute with x plus 2. So it's x plus 2 squared plus 3. So let's do this. So basically, that's the equation. And if I expand it out, really, the 2 and 3 can multiply. So it becomes 6x plus 2 squared. The square does not apply to the 3. It only applies to this bracket over here. So plus 3. So if we look at it, really, there's no change. There's a vertical stretch of 6, but it doesn't change the direction. It still faces up. It's left 2 and up 3. So left 2 and up 3. It's still facing up. Okay, it'll be a lot thinner because it's being stretched vertically now. So, but the domain stays the same as usual. Okay, but the range in this case is y is element of reals, and now y is greater than or equal to 3. Okay, let's go to the next one. 36. So let's see 36. 36 is 2x minus 4 squared. Okay, so let's just write that down first. 2x minus 4 squared. Was there anything else? No, there wasn't that. So what that is simply, now this is the first time we've seen something that'll look a little different. So x minus 4 means it's 4 to the right, and it's stretched by a factor of 2, so it'll be thinner, so it'll look like this. So the domain is x is element of reals, as usual, and the range is y is element of reals. But remember, y still starts from 0 over here, so y is greater than or equal to 0. Okay, let's look at the transformations. The transformations are reflection across y, horizontal stretch by 2, and down 1. All right, so let's look at that. So reflection across y-axis, horizontal stretch by how much? By 2 and down 1. Okay, so horizontal stretch by 2 and then down 1. So g of x is now simply So it's a reflection, so there's no vertical stretch, so there won't be any number in front of the f, so we can just write the f right away. We know there's a reflection across y, so that's negative. Horizontal stretch by 2, which means this is half. There's no left or right, so we can just put x right away. And it's down 1, so minus 1. So remember what we're doing right now is we're taking this argument right here and subbing in for that x over there. So don't forget the 2 and the 4 of the original f of x. So in other words, since this is f of x, I'll just put a big bracket right there, minus 1. So this is going to be 2. And instead of this x over here, we're going to have negative half x. And then we're going to have the minus 4. We're going to close it there and the square there. Okay. So really, if you think about it, all I've done is I've replaced this x with negative half x. The f of x still looks relatively the same. And what we need to do now is, you see, this is not factored. So, and this 2 is not being squared. So I can just remove these square brackets. So it'll be 2. And I can factor it inside this set of brackets here. So it's negative half. So it's x minus, oh no, it's going to be x plus 8. And then I can close it and I can square it. Minus 1. So it's plus 8 because negative half times positive 8 is negative 4. Right? This 2 follows right there. Maybe I'll just move it a little bit so it's clear. So line it up like that. Okay. So this 2 is here. This negative half is over here. And negative half times positive 8 is negative 4, which is what we see over there. So let me just graph this right now. So in other words, there's going to be a reflection. Now, what I'm doing is now I'm sort of graphing it according to y equals x squared. So basically, if you think about it, this is going to be a reflection across the y-axis, so that won't change much at all. And there's a vertical stretch of 2 and a horizontal stretch of 2 as well. And this is negative 8 because it's to the left and down 1. So it's right there, and basically it looks like that. If you think about it from the original function, which was over there, if you look, it's a reflection across y. So if you reflect this across the y-axis, this is 4, it should become negative 4. Now there's a horizontal stretch by 2, so this negative 4 should become negative 8, which is what we have over here. And then it's down 1, so we can see that's pushed down 1, so this is what the graph ends up looking like. So there's 2 ways to do it. You can go to the original and see how that would change, or you can basically write it out the way I've done, and you should get the same answer. So let me write the domain. Domain is x is element of reals, and the range is y is element of reals, but now y is greater than or equal to negative 1. All right, let's move on to the next one, which is number 37. Number 37, so let's just write the function first. X minus 3 squared plus 1. So it's f of x is equal to x minus 3 squared plus 1. And what that looks like is it's 3 to the right and 1 above. So 3 here, 1 here, we got that. And that's basically how it goes. Now, let's look at the transformations that we're going to do to it. Reflections across the x-axis, vertical stretch by 3, horizontal stretch by 2, up 4. Okay, so reflection across, the x-axis. So 3, 2, 4. Okay, so vertical stretch by 3, horizontal stretch by 2, and then up 4. So g of x is basically, across the x-axis, so there's a negative, vertical stretch by 3, so there's a 3. So it's f of x, there's no translation, So it's simply x. Oh, sorry, 1 second. There is a horizontal stretch though. So horizontal stretch is by 2. So in other words, this is half x and then up 4. Okay. So keep in mind, all we're doing is we're taking this argument here, right, and we're plugging into that x over there. Okay. So what I'm going to do is I'm going to put a bracket for the f. So it's going to be -3, and then it's going to put a big bracket, right, and then +4 at the end. So let's look at what's going on here. So this is going to be, some use red. So this half x will replace that x over there. So it's half x and -3 squared plus 1. And that's equal to -3. So let me sort of, let me just factor this inside here. So that's going to be half, and this is going to be x minus 6 squared plus 1 in that bracket plus 4. And that's equal to, so if I expand this, the -3 will distribute to each of these. So it's -3, and this is half x minus 6 squared. This is -3 plus 4. So this is simply equal to -3 half x minus 6 squared plus 1. So if you look at this, there's a reflection across the x-axis, vertical stretch of 3, a horizontal stretch by 2, to the right 6, and up 1. So in other words, this reflection here will make sure that it's going down. It's to the right 6 and up 1. So that's my vertex, and that's just going to go down like that. So the domain in this case is x is element of reals. Oh, and there's no condition. And the range in this case is y is element of reals, and y is less than or equal to 1. Another way of thinking about this is if let me just take this graph right here, 1 second. So let me take that, copy it, and if I move it up here, let's say, edit, paste. Right. So if you sort of think about it, see what we've done. We've reflected across the x-axis. So in other words, if I had to reflect this across the x-axis, if I reflect this across this axis, this will actually become like that, right? So this point 3 here stays, but this vertex now becomes 3, -1, okay? Then I stretched it by 3, vertical stretch by 3. So that means all the y values will become stretched by 3. So this -1 will then become -3 because all the y values get multiplied by 3. So this -1 will become -3. The horizontal stretch by 2. So in other words, all the y values, all the x values get multiplied by 2. So the new coordinate will basically, let me use a different color. The new coordinate will basically become right here. Oh, maybe that's not a good color. Maybe I can use green. That's a bit better. So the new coordinate will become this coordinate right here is -3. It's -3 because remember the -1 here gets multiplied by 3, so it's -3, and then the horizontal stretch by 2. So this value of 3 gets multiplied by 2, so it becomes 6, right? So that goes like that, and then it's up by 4. So in other words, I'm adding 4 to the -3. -1 plus 4, -3 plus 4 becomes +1. I think this might be a little bit confusing, so let me just show it again. Let me just scroll down. So let's go back to the original function. The original function was f of x is equal to x minus 3 squared plus 1. So the original function looks like this. So there it's 3, and this is 1, and this is facing up. Okay? So let's do it step by step. So the first step was they said it's a reflection across the x-axis, right? So if there's a reflection across this axis like right here, basically it will look like this. Okay, so this point is still 3, but this point, since it's reflected, becomes -1. That's just a reflection across the x-axis. The next thing was, let me just use a different color. Let's use green. So there's a vertical stretch by 3. Okay, so if there's a vertical stretch by 3, that means all the y values get multiplied by 3. So notice this -1 becomes -3. Okay, and everything else just sort of gets stretched. So let me just extend the page a little bit. So everything else gets stretched, so it kind of looks like that. Okay, that's the vertical stretch by 3. Then there's a horizontal stretch by 2. So which means if there's a horizontal stretch by 2, all the x values get multiplied by 2. So this value is 3, so then now we have a value of 6. So this will become like that. So it becomes like this, right? So our new coordinate right here is 6, -3, okay? And then the last bit said, let's see if I can use this color. Okay, the last bit said it's up by 4, okay? So in other words, this red line will move up by 4. So if -3 plus 4 becomes like that. So that's why our coordinate here is 6, 1, because it just moves up to 6, 1. So that's basically how the transformations work. They go from here, they reflect here, it gets vertically stretched, then it gets horizontally stretched, and then finally it gets moved up. And we end up with this purple line over here. And if you look, 6, 1, it's 6, 1. It's basically the graph that we have over here, 6, 1. And that's how we get our domain and range. I hope that sort of clarified things. Now we have 3 more problems. Let me go back here, white. So 38, let's go here. 38 is, so now this is kind of like one of those backward problems, and I'll explain what I mean by that in a second. So here we're trying to go from F to G over here. So let's just do that. So F is -3 x minus 2 plus 1, x minus 2 squared plus 1. And we're trying to get to g of x, which is simply x squared. Now, we're trying to go from here to here, right? Let's actually do the opposite. Let's try to go from g to f. So let's just say we were to go from g of x to f of x. So if we were trying to go from g of x to f of x, what you can, so in other words, we're trying to go, let me just draw this in red. So I'll draw this in red as well, okay? So if I'm trying to go from g to f, I can see that first there's a reflection across the x-axis. So reflection across x, okay? Then there's a vertical stretch by 3. There's a vertical stretch by 3. Then we have to move right 2. We move right 2, and then we move up 1. We move up 1, and basically that's, let me just show that there. So that's going to give us at the very end, going to give us at the very end f of x, right? And it sort of makes sense because we're going to go from x squared to that, which makes sense that we would go from g of x to f. Now, but the question asked for the exact opposite. The question said, how do we go from f of x to g? So if we're trying to go from f of x to g, then let me just draw this in green. So in other words, this is the way that we're trying to go. This is the way that we're trying to go. So it's the exact opposite, right? So if we want to go from f to g, we have to go, so if this was up 1, if we're going backwards, this would be down 1, and then the opposite of that would be left 2. Now vertical stretch by 3, so it's a vertical stretch by 1/3. And finally, the reflection just stays the same. We're just reflecting back. So again, it's a reflection across the x-axis, not the y, because all we're doing is just doing a re-reflection, so another reflection. And so that's how we get to g of x, right? So this is basically the backward transformation in order to get g of x. So it's kind of like here, before, in this case, we were doing like R, so reflection, then stretch, then translation, and now we're doing the exact opposite. We're doing translation first, then we're doing a stretch, and there's the reverse stretch, and then, so it's like, here we're going R, oh, sorry, let me just use a different color. Here we're going R, S, T, and if we're going backwards, we're going T, S, R, right? So that's sort of the backwards translation. And 39 will pretty much follow the same structure. So let's do 39. 39. Let's do that. I'm not going to sketch it out because I think it's pretty straightforward. All we just need to do is the backwards translation. So we're trying to go from 2x squared. So let's just say, for example, we're trying to go from f of x to 2x plus 5 minus 3. Okay, so f of x is 2x plus 5 squared minus 3, and g of x is simply x squared. So we are trying to go from here to here, but let's do the backwards because that kind of just makes it a little bit easier. So if we go from g of x, and we're going, then what we do is a vertical stretch by 2, we'd go left 5, and then we'd go down 3, and that's how we would get f of x. All right, so that's the backwards translation, but we want to go from f of x, right? We're trying to go from here to here. So if we're trying to go backwards, then it's going to be up 3, it's going to be right 5, and the vertical translation, it's going to be vertical translation by half, because we want to get half of what we had before, and then finally that's how we get g of x, right? So look, basically all we're doing is just doing the reverse translation in order to go from f to g. Finally, our last one, which is number 40. All right, so let's do the last one, which is number 40. Right, it's basically the same thing as the other two. So negative 4x plus 1 squared plus 2. So f of x is negative 4x plus 1 squared plus 2. And then g of x is simply x squared. So we're trying to go from f of x to g of x. But if you observe, it's actually a little bit easier if we try the other way around. So trying to go from g of x to f of x. So if we wanted to go from g of x, which is x squared, to f of x, which is that, you can observe that first there's a reflection across the x-axis. So there's a reflection across the x-axis. Then there's a vertical stretch by 4, as over there. Then we go left 1, and then we go up 2, and that's pretty much how we get, let me just scroll down a bit, and that's pretty much how we get f of x. Remember, we're not trying to go from g to f, we're trying to go from f to g. So really, if we want to go from f to g, it's kind of the backwards transformation. So if we're trying to go from f to g, as we see over here, then the easier thing to do is just go in reverse. So if it's up 2, then we go down 2. If we go left 1, then we go right 1. Vertical stretch by 4, so it's a vertical stretch by 1/4. And so for reflection across the x-axis, we just re-reflect. So it's not a reflection across y, it's just a reflection across x again. And that's how we end up with g, right? So we're just going sort of the reverse order in order to get to g. And all right, so that's our solutions for the square roots and quadratics, and I'll see you for the next video. Bye.